we're ready to go. So let's get started tonight's meeting with Chris Vaughan and the sky this month. Go ahead, Chris.
So tonight I'm going to cover what's going on in the night sky between tonight and the first Tuesday of February, which is the day before our next RASC, Recreational Astronomy Night meeting. You might enjoy this nice background slide I've had here. This is a deep, long exposure photograph of the southern half of the constellation Auriga, the Charioteer, and this is a sampling of some of the nebulas and open clusters that are hidden treasures inside that constellation. So I recommend checking that out. So what I'm going to cover is a bit on space exploration news, launches, things like that. I'll review some events in history during January, and then we'll get into observing things to do with the sun and the moon, the planets, comets, asteroids, satellite passes, and then some observing suggestions for variable stars, doubles, and winter targets, etc. And following the presentation, I'll upload the notes for this meeting, this presentation, to our website, RASC-Toronto.ca. So in case you're feeling that you want just the bullet point headlines of what I'm going to talk about in more depth, here's a sort of bullet point list of some of the milestone events covering the next few weeks. So right now we're entering a dark sky moonless viewing period, so that's great. We have long nights to use those with. On January 10th in the evening, we've got the variable star Algol brightening from its minimum. On the 10th, that Sunday, we have a really close meetup of Jupiter, Saturn, and Mercury low over the western horizon after sunset. And then on the 16th, the moon will be turning to make its eastern limb more favorable for us to view some of the features on the edge of the moon. On the 20th of January, we've got Mars doing a close flyby of Uranus. They'll be telescope close. On the 21st, I'm going to suggest you take a look at the lunar straight wall. We've got an asteroidal occultation on the 22nd, and then to finish the month, last week of the month, we've got Mercury at max visibility and maximum elongation. In space exploration, not too much going on in launches right now, except for there's a large number of to be announced Falcon 9 rockets, launching more Starlink satellites and other small commercial CubeSats and microsats. But this other launch opportunity is one to look for. This is the Virgin Orbit Launcher 1 rocket, which is the little rocket you can see strapped to the undercarriage of Cosmic Girl, their Boeing 747, launching from the Mojave Air and Spaceport in California. And they're launching CubeSats for NASA field centers and some educational purposes and so on. But that's a neat, another way of commercial space exploration ramping up these days. Looking back in history, so on January 8th, 1942, we celebrate the birthday of Stephen Hawking, theoretical astrophysicist, author, TV personality. I guess he hoped to be an astronaut, but unfortunately we lost him in 2018. Then on January 10th, we celebrate Robert Woodrow Wilson. He co-discovered the cosmic microwave background radiation. Way back in 1642, on January 8th, we lost Galileo Galilei at age 78, but we celebrate the birth of Doctor Who in 1908, William Hartnell. On January 15, 2014, someone that's near and dear to many of us in amateur astronomy, it's John Dobson. He lived to a ripe old age of 98. He's the one that developed the Dobsonian telescope that many of us use today. You can see a sort of an earlier, less refined version of a Dobsonian reflector there on the lower left. On January 16th, it's Jill Tarter's birthday, American SETI pioneer, search for extraterrestrial intelligence, and radio astronomer. And here she is sitting, I'm sure, at one of her favorite places on the Arecibo radio telescope that we recently lost due to its collapse. Back in 1611, January 28th, Johannes Hevelius. What a man, Polish astronomer, lunar cartographer. He worked on libration. He built a 46-meter-long focal-length telescope, tubeless telescope. He discovered 4 comets. He named the star Myra, which I'm going to touch on later on. He identified a number of modern constellations and more. Here's a picture of his telescope. And there's one of his moon maps. In space exploration, back in January 19th of 2006, the New Horizons mission launched. It's the one that flew past Pluto and then the Ultima Thule Kuiper Belt object. On January 25th, the Opportunity rover landed on Mars. January 27th, the sad anniversary of the loss of the Apollo 1 crew of Grissom, Chaffee, and White perishing in their capsule due to a fire during training. And then again, another sad anniversary for NASA is the shuttle Challenger exploding shortly after liftoff at the end of January. In astronomy this month, we celebrate Galileo turning his new spyglass to the heavens and beginning to observe the craters and mountains on the moon, seeing that there are spots on the sun, watching the moons revolve around Jupiter, and capturing the phases of Venus. Really started astronomy, visual astronomy for everyone. 1939, we have the Scottish astronomer Thomas Henderson publishing the first stellar parallax measurement. That's using the orbit of the Earth, the Earth's position changing due to its orbit around the sun causes the position of stars to be detectable, and we can calculate using trigonometry their distance. 1969, we have the discovery of the first optical pulsar in Messier 1, that's the Crab Nebula, by John Cook and Michael Disney using the 36-inch telescope at Kitt Peak Observatory. And on January 17th, we celebrate Edwin Hubble publishing his paper that declared that the universe is expanding. And there's the red line running through his data points, showing that expanded distance over velocity. In 1862, Alvin Clark, the Clarks were famous telescope makers, discovered Sirius B, the little white dwarf star that's tucked in close to the bright star Sirius. There's a little arrow next to the Sirius B. People call it the pup. I prefer calling it the flea. And on February 1st, the first light for the 200-inch Hale telescope at Mount Palomar, California. I don't know if you can notice, there's a whole crowd of people sitting underneath the telescope, just to give you a sense of scale. Let's get into some observing. This is a fantastic picture of the region near Alnitak. So Alnitak is this bright star. It's the left-hand star of Orion's belt. The rest of Orion's belt heads up to the right here. And this was taken by Michael Watson, one of our Toronto Centre members. And I just wanted to point out that we have the Horsehead Nebula here in this long exposure. We have the Flame Nebula tucked in close to the star. And then we have this little grouping here. This is Sigma Orionis. And this is one of the multiple star recommendations for viewing multiples this month. Rascals are invited to help with mapping light pollution through the globeatnight.org organization. So during the dark of the moon every month, they choose a constellation and they ask you to estimate how many of that constellation stars that you can see visually from your location, and then log those readings into their database so that they can figure out how light pollution is distributed across the world, and also how it varies over time, how it's getting worse, normally getting worse. So this month, between now and the 13th of January, they're focused on the constellation of Orion. And you can get more details at www.globeatnight.org. Sunrise and sunset is important for astronomy. Right now, the sun is rising at about 7:50 in the morning and setting around 4:56 p.m. And that gives us 9 hours of daylight. But by the time we get to our next meeting, the amount of daylight will be increased to 9 hours and 58 minutes. So our nights are getting a little shorter, our days are getting longer. Here's a graph of the bright blue is the amount of daylight per day, and the dark is the amount of night per day. You can see that the wedge as the daylight lengthens with each passing day. Astronomical twilight is important to astronomy. When the sun is more than 18 degrees below the horizon, the sky is as dark as it's going to get, not counting the moon and other things, the light pollution and so on. So imagers that want a dark sky, they need to wait till the sun has gone well down and then finish their job, their imaging, before the sun starts to rise in the morning. Right now, the astronomical twilight, the full true darkness occurs after about 6:39 p.m. and the sky will begin to get light around 6:07 a.m. tomorrow morning. So that gives the imagers about 11 and a half hours of imaging time, but that's decreasing by a minute and a quarter every day. 4 weeks from now, we'll be down to 10 hours and 45 minutes of imaging, and the days will be lengthening. Daylights will be lengthening, the nights will be shortening by 2.5 minutes per day. So here's a graphical overview of what the moon is up to this month, starting at tonight's meeting on the January 6th and then running to the February 2nd period that I'm covering here. So we see we're at the third quarter or last quarter moon tonight, and then the moon will wane towards new a week from now on the 13th, and then it'll reappear in the evening sky for first quarter, and the full moon will occur towards the end of January on the 28th. For those interested in dark sky viewing, we want to take a look at those dark skies between about now, at last quarter, third quarter, and within a day or two after new moon, when the moon begins to sort of linger in the western horizon after sunset. It goes down early, leaving the rest of the night nice and dark. So this is our dark sky viewing, best dark sky viewing period. Now, if you want to look at the moon itself, the best time to do that is when it's waxing in the evening, and that will be starting up around the 15th, 16th of the month and extending through that first quarter week, the week sort of surrounding first quarter. And while the moon is waxing, a number of topographic features on the moon become very, very nicely positioned and enhanced for our viewing, including things like the lunar straight wall, the golden handle. And as the moon gets towards full, because COVID-19 is keeping more of us near home, we're not able to necessarily go out to our dark sky sites. I'm encouraging people to spend time looking at the moon. So the moon is going to be visible in our evening sky for most of the rest of this month, all the way to February 2nd or so. In the winter, the moon is higher in the sky, so we're getting sharper views of it through less of the atmosphere. Don't forget, you can view the moon in the morning daytime too. So get the telescope out, cooling down overnight, pull it out in the morning. And you can use a polarized filter. You could take you can get a polarized filter for the moon, or you could just take a pair of 3D glasses from the cinema and rotate the glasses through 360 degrees, and you can darken the sky and enhance the contrast on the moon in the daytime. So that's a neat trick. Now the moon does this wobbling and nodding through the course of the month. That's because its orbital inclination is tilted 5 degrees to the Earth's to the ecliptic, and because it has an elliptical orbit around the Earth, and that means that that the center of the moon rises and falls and drifts left and right through the lunar month. That's called libration. And over time, we can see about 59% of the moon's Earth-facing hemisphere. So the Observer's Handbook of the RASC lists for each month the times when the moon is most tilted left to east to west to north to south. And I've got some suggestions here. So on the 16th of January, the moon's eastern limb, that's the side that it's filling with light from during the sort of post-new moon period. From the northern hemisphere, if you're looking at the moon, the eastern hemisphere of the moon would be on the right-hand side from a viewer standing in the northern hemisphere. So on the 16th, the moon will be tilted so that we can see more around the corner on the eastern side, and you can look for things that are normally elusive, things like Mare Smithii, Mare Marginis, and the crater Hubble. The librations for the northern limb happens in darkness. That's not helpful. The moon's western limb is exposed when the moon's full. That's not as helpful either. And when the moon's southern limb is most exposed, it's going to be rising in late evening, and there are a few features listed here that you can attempt to see during those favorable librations. So here's just a quick example, a picture taken when the moon is not librated favorably on the east, and then when it is. And so this would be an example of being able to see this dark smudge of Mare Smithii in the sort of northeastern quadrant of the moon's disk. A few days later, when the moon is getting towards past first quarter, so a day or two past first quarter, we can favorably see this lunar straight wall, otherwise known as the Rupus Recta. It's 110 kilometers long. It's sort of runs across Mare Nubium. And Mare Nubium is the dark patch, the dark mare that sits just above the crater Tycho. When you're looking with your binoculars, you should be able to pick that out. Good binoculars might see the straight wall. Certainly any size of a telescope will be able to see it. And that feature is illuminated from the right a few days after first quarter, and then a few days before third quarter, it's illuminated from the left. So it gets a bit of a different view. The golden handle effect is produced when the former rim of a crater named that's now known as Sinus Iridum, or the Bay of Rainbows, it sits on the edge of Mare Imbrium. and part of the crater has been submerged under the basalts that flooded Merimbrium, leaving just a half of it exposed. And a few days before the full moon, the shallow sun angle lights up the eastern side of that curved wall. We call these the Jura Mountains. And where the crater edges dive into the Merimbrium, we get these little points, promontories. This is Heraclides and the Plas. And so the effect produces kind of a teacup handle shape on the edge of Merimbrium we call it the lunar handle. Once you've got it, you can certainly see this with unaided eyes and binoculars and telescopes. But then grab your telescope, zoom in, and see if you can see the dorsi. Those are wrinkle ridges that kind of run north-south through Meridiem. Now here's a cool resource that a number of us are using lately. It's called the NASA Dial-A-Moon. So you can go to this website, and this has, for every day of the year, 2021, and for every hour of that day, a picture of the moon properly illuminated as you would see it from Earth. And so what you can do is you can dial up using universal time, the date and time, and it'll show you a picture of the moon. Then you can click on that picture and it'll download to your computer a TIFF file, a very large TIFF file, many megabytes in size, with a high resolution annotated view of the same moon. And you can get a version that's right way up or upside down if you wanted to use it at the eyepiece for a telescope. This is a great way to confirm when the lunar X is scheduled to appear. You can see the lunar X building every hour by hour and declining when it's done. So it's a great resource. As the moon gets towards full later this month, around the 26th to the 30th, that's when we're starting to see the lights and dark patches on the moon are more caused by the moon's geology as opposed to by its topography and by shadow effects. And so what you can look for towards the full moon period are these ray systems emanating from some of the craters. That's the ejecta that was blasted out of the craters and strewn across the moon's surface. There are ejector craters around Tycho and Copernicus. There's a neat one named Proclus, which is an ejecta pattern that's not 360 degrees, but it's only about 2/3 of a circle because the object that made it came in at an angle. And speaking of that, there's another one called Messier, and it's called Messier. The craters are called Messier because the rays produced by the object that hit was coming in at such a low angle that the debris was spread in only one direction, producing this sort of appearance of a comet through your telescope when you're looking at the moon. The Messier pattern is sitting here in Mare Fecunditas, and it's on the right-hand side of the moon's near facing disk. So when the moon is near its full phase, it's opposite the sun in the sky, and that means that all of the light landing on the moon is coming in at a very steep angle. And when that happens, it accentuates features like the terraces surrounding the crater Copernicus. This is the large crater in the upper sort of central western half of the moon's near-facing hemisphere. And so here's a magnified view of this sort of cliff edges. You can see all the way around the surface of the edge of the crater due to the material slumping inside the crater, so these terrace effects. Another thing to look for are the little craters with dark halos around them. So in the area around Copernicus, we have the dark gray basalt underneath, and then we have the brighter material that was ejected when Copernicus was formed, forming a skin of white rocks sort of strewn on top of that. And then if an impactor comes in later, punches a hole in that, it excavates down into the dark basalt and spreads its little ring of ejecta on top of the Copernicus, the bright Copernicus ejecta. So we get, instead of having the normal effect of a crater with a white ring around it, we have craters that have little dark rings around them. And there are a whole bunch of them inside the ejecta blanket surrounding Copernicus. That's a terrific thing to look for in a telescope. You can also, at the full moon, look for the dark stains left by now dormant volcanoes on the moon. And so one of the best places to look for that is just below the center of the moon's disk, the crater Alphonsus. And here's a picture by Gary Saronic of the Alphonsus crater. And you can see these three dark stains in a triangle. And these are former cinder cones of volcanoes that have since gone dormant, but were active at some point in the past on the moon. Another pair of them can be seen up here in the crater Atlas. The crater Atlas is sitting up here towards the upper northeastern vicinity of the moon's disk. So those are some neat things you can look for, especially in a telescope. The Alphonsus dark stains are quite prominent, so you don't need a big telescope to see those at all. All right, let's move into the planets. So we're actually entering a period now where we're going to be losing most of the planets. We still have Mars up in the sky, but it's not as prominent as it once was. But just before we lose Jupiter and Saturn after their terrific great conjunction a week or two ago, we have them still sitting low over the western horizon after sunset. But what's happening over the next few days is that the little speedy planet Mercury is going to be climbing up to join them. So between about the 9th and the 12th of January, Mercury will be climbing up, passing Jupiter and Saturn. Jupiter will be more visible because it's brighter than Saturn is. But if you grab your binoculars after the sun is safely set, you can take a look for them. So this is Sunday. I'm showing you the view on Sunday evening, January 10th, when they'll form a neat little triangle about 2 or 3 degrees separate from each other. So this big circle here would represent binoculars field of view. And this arc I'm showing through Mercury is showing its orbital path. So it's going to be every night climbing up a little bit. So the night after the 10th, Mercury will be a little higher and so on. And then on the 14th, just several days later, we're going to have Mercury sitting about here, and then we'll have a young crescent moon forming a neat little line of the moon, Mercury, Jupiter, and Saturn. Just after sunset, you've got to be fast before they get too low in the west. Speaking of Jupiter and Saturn, they're gone into the sun and solar conjunction, passing solar conjunction on the 24th and the 29th of January, respectively, and they'll re-enter the eastern pre-dawn sky later this year in a month or two. That vision of Mercury, that appearance of Mercury, will last all through the month of January and into early February. So it's a great time for us in the Northern Hemisphere to see Mercury. Not so lucky for people in the Southern Hemisphere. The geometry works differently and they don't get as good of a view as we will. Mercury will reach the tip of its orbit out here, called eastern elongation, on January 23rd. And it'll be best visible over a good window, 5:30 to 6:30 p.m. in the southwestern sky. If you use a telescope on Mercury, you're going to notice that the disk is nearly fully illuminated, and that the disk size itself will grow in size quite a bit, from 5 arc seconds to 9 arc seconds over the next 4 weeks. Venus has been up in the pre-dawn sky for months and months, but we're losing it now. It's swinging back towards the sun. By early February, it'll be all but gone, impossible to see anymore. But in the meantime, it's shining at a very bright magnitude 3.9. If you put your telescope on it, you're going to see, again, a not quite full disk. It's a waxing, nearly full phase. Its disk size is much bigger than Mercury's. It's about 10 arc seconds. And when you're up early, you want to take a look, see if you can see Antares shining off to the west, the star Antares. And on the 11th of January, we've got the old crescent moon sitting just about 5 degrees to the right of Venus in the pre-dawn sky. And this is your binoculars field of view for reference. As I said, Mars is still nicely placed for viewing in the evening sky. It's nice and high. After sunset, it's already quite near its highest point around 7 p.m. in the evening. A month from now, that'll be happening about 6 p.m. So we're starting to get Mars more into the western sky, not quite as high as it is now. But it's much dimmer and much smaller in a telescope than it was during opposition in October. It's already about, I think, about a tenth as bright and quite a bit smaller. But Mars is speeding along the ecliptic, and on the 20th of January, it's going to make a very close pass with the blue-green planet Uranus. And this circle I'm showing here is a 2-degree field of view. So they're pretty much telescope close if you use a low-power eyepiece, low magnification eyepiece. And then you can catch the blue-green planet, dimmer planet, with the bright reddish planet in the same field of view. Beware, though, that Mars will be about 160 times brighter than Uranus. So that same night, when they're closest, we've got a first quarter moon just below them in the sky. It doesn't do Uranus any favors, but if you're using your telescope, finding Uranus with Mars's assistance, then you should have no trouble seeing it. Mars is just going to keep getting dimmer and smaller as Earth continues to pull away from it. It'll be lingering in the sky for a number of months, but it's just not the fine target that it once was. Neptune is also available in the evening sky. It's a little bit lower than Mars and Uranus are, so we have less of a window to look at it. It's sort of an early evening target. It's in Aquarius. It's about a magnitude 7.9, which is certainly within range of any size telescope if you know where to find the planet. And what you can do is you can look for these set of quite prominent stars. They're not super bright stars. They're medium bright, but they're in the sort of knee of Aquarius here. We have Phi Aquarii, Psi, and Lambda. And they form a kind of a triangle. The Neptune is just a little bit to their upper left of Phi, about 1 finger width or one degree. So you could try for that. And that distance between these two will actually increase a little bit over the next few weeks, but it'll still be in the same vicinity. Don't forget that the asteroid or dwarf planet Ceres is tucked also in Aquarius. It's down here near the bottom of the field of view I'm showing you. Speaking of asteroids, the asteroid Vesta is hanging out near the tail of Leo, the lion, in the eastern sky. It's kind of an overnight object, maybe from late evening into the pre-dawn. And it's about 4 degrees, so about 3 or 4 finger widths to the right of the Nebula, the tail star of Leo. And on the 23rd of January, Vesta will start a little bit of a retrograde loop. This path is showing it sort of turning direction and heading back the other way, which it'll do through its opposition in April, and then it'll finally finish this retrograde loop in late April. If you're interested in variable stars, Algol is one of the most accessible variable stars for beginner astronomies. It's an eclipsing binary system. That means there are 2 stars in the system, and one star passes in front of the main star and dims the total light output that we see. And that's because the orbit of the 2 stars is in the line of sight to Earth. So that means that we can see them, the one star passing across the other star. We can't see the stars doing it, but that's the effect, is to dim the light. So normally Algol, or Beta Persei, which is sitting here, it shines at a magnitude of 2.2, and that's comparable to this star Almach, which is at the end of Andromeda. But every 2.87 days, as the little star passes in front of the main star, the total brightness drops to magnitude 3.4 and back for over a period of about 10 hours. And the magnitude 3-point star is similar to this star right beside Algol called Rho Persei. So by getting out and looking and see, does Algol look the same as Rho Persei? Does it look brighter? You can get a sense of where it's at in the cycle. Here's just a graphic of how the light output decreases when the 2 stars are lined up. So on Wednesday, January 20th at 8:53 p.m., that's the scene I'm showing here, Algol will be already at its minimum, so it'll be similar to Rho, and it'll start increasing over 5 hours. As it does that, it'll sink a little bit into the western sky. Or you can flip it around, and you can, knowing when it's going to be at minimum, you could start watching 5 hours ahead and watch it decrease. So on Sunday, January 17th at 7 p.m., it'll be at its regular brightness, but 5 hours later, it'll be down at the dim point at the magnitude 3.4. Another famous variable star is Myra, which is sitting here in the neck of Cetus, the sea monster. This is a view looking southeast at 7 o'clock tonight. So it's sitting right there in our evening sky. Here's Orion, just for reference, and Taurus. So this is a pulsating variable star. It's takes about 100 days to brighten up, and then it takes about 220 days to drop in brightness. So it does this periodically, cycle after cycle. And this is a graph of the brightness over time for the last 700 days. So we're sitting right here at now, and it's about magnitude 6.2. So it's right in the middle of its range right now, heading down. So it's something that you could keep an eye on, make a note of looking at now and again. Some other great double stars that we can talk about. So I mentioned that Sigma Orionis that was earlier in the picture that Michael Watson took. This is where it's located. It's about a finger's width to the lower right of Alnitak, the bright star in Orion's belt. It's a beautiful magnitude 4 star, a long dart-shaped multiple, 49 arc minutes in length. Here's another nice double Iota Cancri in Cancer. It's a blue and yellow pair, separated by 30 arc seconds. And then down here, this is a real showpiece. This is 145 Canis Majoris. Sometimes we call it the winter albireo. Albireo is a beautiful blue and orange or blue and yellow star that we look at in the summertime, and this is comparable. It's the same sort of idea. And don't worry about the fact that it's sitting quite low in the sky in this view. Canis Major rises as the evening goes on. So this is 9 p.m. In the next number of weeks, this will be getting higher and higher and nicely positioned for viewing that double. A shout out to Blake Nancaro, who's been sharing every month suggestions for double stars to look at. And he's also organized an RASC double star observing program, which you can find here at this link. And I'm not going to talk through these in detail, but I'll just show the list, and people can grab a screen cap and note which these nice double stars to chase on the next clear night. Nice thing about double stars is the moon can be at any phase. They cut through the moon, so you don't need to wait for a dark sky the way you would for a nebula or a galaxy. If you're chasing the International Space Station right now, it's showing up in the pre-dawn. That'll last until about January 10th, and then starting on the 16th, we'll be seeing the International Space Station in the evening sky between about 6 and 7:45 p.m. And here are a number of upcoming passes that if you want to make a note of. And you can use the website heavens-above.com and enter your location, and it'll give you a list of all the passes of the International Space Station for where you live. Lunar occultation, or asteroidal occultation. So occasionally we get lucky, and an asteroid in the solar system will pass in front of a star and dim that star's light, and that will allow us to actually measure the shape of that asteroid and tell us more information about the object. So here's an event that's happening not too far from the Toronto area. On January 22nd in the late evening at 11:28 p.m., an asteroid by the name of 333 Badenia, which is itself a magnitude 4.2, which is very dim, will occult a relatively easy to see star with this fancy name. The star brightness will dip by almost 4 magnitudes, which is quite dramatic, for 12.4 seconds. And it's located in the constellation of Taurus, which is nice and conveniently positioned in our sky. And the predicted path of the max occultation runs right through Hamilton and out through southwestern Ontario. But anybody located between the blue lines are in the error bars for the event. So if you're wanting to head down into Milton, Cambridge, KW, Woodstock area, even Niagara Falls, St. Catharines, you have a chance of catching that event. The more people that can observe the event and time it and can submit their information to the sites that do that are contributing to citizen science, because then they're helping us work out the actual shape of the asteroid. Here's a star chart or star field showing the actual star that will be dimmed. It's about a few degrees from Elnath, which is the upper star of Taurus's horn, the northerly horn tip of Taurus the bull. So it's in a conveniently placed neighborhood. We like to look at objects when they're highest in the sky, because that way we're looking through the least amount of atmosphere. The lower things are, the more blurry they look, but when they're nice and high, we get to see them more clearly. And so I'm showing you here a sky chart for January 9th, which is sort of nicely into this dark sky moonless period at 7 p.m., so shortly after dusk. And the objects that are crossing the meridian, so objects rise in the east, they're highest when they're in the south, and then they decline in the west. So when they're crossing this green meridian line is when they're at their best, even if they happen to be low in the southern sky. It's the best that we get. So the objects that are the constellations that have objects in them you might want to chase down include Sculptor and Fornax, which are very challenging objects for us in southern Ontario. But then the ones that are higher in this lower air mass range would be Eastern Pisces, Aries, Triangulum, Andromeda, Western Perseus, and Cassiopeia. So those are the kinds of things you'd want to chase down. 2 hours later, we're starting to see the winter Milky Way heading towards the meridian. So the showpieces embedded within that would be good form. So we have, again, we have the constellation Eridanus coming up here. We have Taurus, Eastern Aries, Perseus, and Camelopardalis. By 11 p.m., we've got the Milky Way right on the meridian, so we're getting those great nebulas and star clusters in Auriga that I showed at the top of the talk. We've got Orion at its best. We've got Gemini and Taurus and so on. And if you stay up really late, you're past 1 a.m. and beyond, you're starting to get into the spring galaxies over here in the Leo and Coma Berenices by 2 o'clock in the morning, 3, 4 in the morning. These are getting nice and high in the south. So I'll probably wait and view them in a few months, but if you're keen to get galaxies, you can even start now. I often recommend that people who commonly look at the Messier objects to consider other objects that are not on the Messier list. So the Messier list produced by Charles Messier had 110 objects, but they're not meant to be the best of the sky. They're meant to be things that confused he and his fellow comet hunters because they resembled fuzzy faint objects that were sort of comet-like. So I can recommend some non-Messier objects that are fantastic winter showpieces. They include the Rosette Nebula, which is here. If you don't have a very dark sky, you can still look for the bright star cluster in the heart of the nebula. The Rosette is an emission nebula. It's more than a degree across in the sky. It's a fantastic object. You can see it even with binoculars if your sky is dark. And in the Observer's Handbook, Alan Dyer, a RASC member, has produced a recommended list of another 110 objects called the Finest NGC list. And this is object number 32 in that list. Some more, not far from the Rosette, there's an object called Hubble's Variable Nebula. It's a tiny but bright little comet-shaped nebula. I can show it to you in a minute. It's number 33. Then there's the Parca Nebula. I'm proposing that we call this object the Parca Nebula. Some of you will know it as by another name. It's NGC 2392. It's a planetary nebula in Gemini. You can use the averted vision blinking effect on this nebula, but you need a lot of magnification. It's a tiny object. Then one of my favorites for star parties and outreach is the Dragonfly or Owl or ET cluster in Cassiopeia, NGC 457. And then we have NGC 891. It's actually an edge-on spiral galaxy. When galaxies are on their edge, they're brighter in the eyepiece. And so this is a really accessible object for smaller telescopes. It's sitting not far from that star Almanac that I mentioned earlier on. Just let me finish up fast here with a view of some of these objects, just to give you a context of where they are. So here's Orion, here's Monoceros, and here's the Rosette Nebula, the little oops, let me just get this out of here and go back to here. So here's that little tiny comet-shaped Hubble's Variable Nebula I mentioned. You can see that it's not far from the Rosette. And if you keep going in the same direction, you come to a fantastic object called the Christmas Tree Cluster. Here's that planetary nebula I was talking about. It's over here near the waste stars of Gemini. And to finish up, here is the ET cluster, the Owl cluster in Cassiopeia. It sort of sits in the middle of the W of Cassiopeia. And last but not least is this terrific edge-on spiral galaxy. And with that, I think that brings me to an end. Thank you.
All right, thank you, Chris. Very thorough. The sky this month. I typically don't like the moon because it interferes with deep sky observing, but you certainly pointed out a lot of interesting stuff to look at on the moon. Thanks for that. So let's go over to Blake for any questions.
Hi, thanks. We do have a couple of questions. Chris, you Parks in the YouTube chat asked when the Lunar X date is, and I didn't recall that date. Do you have it handy?
I can get it for you. Let's see here. The next Lunar X that I have listed, let's see. I have one on March 20th.
March 20th?
Early evening.
Okay, thanks.
Yeah.
And I had a question for you on the moon again. Lunar X is sort of one night only, right? But the straight wall is not. Do you have sense of sort of the latitude, how many sort of hours we can watch it over, or maybe is it more than one night?
Yeah, so it's visible once the moon fills to that phase. It's visible. Let me just get my time up here.
I guess
So
there's kind of a change in the angle of the sun, so you get a long shadow maybe versus a short one.
yeah, so it doesn't become visible until the terminator gets past it. So after there's first quarter the evening before, a couple of nights after first quarter, now that mare nubium is being illuminated by shallow sunlight. So after this point, it's visible for a number of nights. It's just going to be most apparent about 2 nights after first quarter, but it'll still be visible for several nights, perhaps slightly less intensely after that.
Right. Okay.
But it doesn't disappear. I mean, it's there.
Right. Good. All right. Thanks a lot. That's all that I see. I'm having a quick look here. That's all I see in the YouTube chat. Thanks.
All right. Thanks again, Chris, for your presentation.